In geology classes, we talk a lot about plate tectonics, and we have this assumption that our plates are moving. And that is happening. Our tectonic plates are moving. But why is that even happening? Let's take a look at that. So first we need to talk about convection. That's a process that's going on in the mantle that's going to help us understand that. And so I have a picture of a lava lamp, or at least I've drawn one. And you'll see here that I've got this more dense liquid at the bottom of the lamp, and then there's going to be some other less dense liquid that's sitting at the top there. And the way that a lava lamp works is that you press the button, the light inside the base is going to turn on, and it's going to heat up this green material here at the bottom. And as that material gets heated up, it's going to become less dense, and it's going to rise up like this. All right, because the density has dropped. So it's going to go up because it is warmed like this. All right, and then as it gets higher up in that column of less dense liquid, it's going to cool down. And as it cools down, the density is going to increase again, and then it's going to sink back down like this, down into that pool. And so we would do that in two directions, actually. All right, and that's called convection. So it's a way to transfer heat. And where you have the rising liquid as it gets warmed up and less dense, and then as it cools, it becomes more dense and sinks back down. So we always know the expression like hot air rises, right? And that's how hot air balloons work and things like that. And that's just because air and fluids that become hotter are going to become less dense and will rise up. Okay, so that's the process of convection. So let me write that, convection. Okay, so now we need to think about, that's a C, there we go. We need to think about where that's happening inside of our Earth's interior. And so we have our tectonic plate here. And if we remember, our plate is actually made up of the crust and our solid upper mantle. Okay, because that's all solid. So the composition changes from crust to mantle. We don't care about that. We just care that it's solid. Okay, so this is my plate. And below that is an area of the mantle that's actually called the asthenosphere. And it's kind of this waxy, plasticky layer down there. And this is where we have our convection occurring. So the core is down here. That's like the light down in our lava lamp. And then our asthenosphere is acting like this green liquid here. And so it's going to rise up as it heats up and then cools and then sinks back down. And so you can imagine that there's these currents that are developed. And so if I create that current, let's say it's doing something like this here. All right, so there's going to be something called slab suction between the plate and this moving asthenosphere. So let's write that down. So here is where we have slab suction. And we'd have it here as well. Okay, that's causing that plate to move. So it's going to drag the plate with it. Now we see here, because we've got this these two arrows moving opposite of each other, we might create something like a divergent plate boundary here. But the general idea is that we just have this slab suction as the moving asthenosphere is carrying that plate with it. Let's look at two other things that cause the plates to move. Now let's take a look at two other reasons why our plates move. So we've established the fact that down here in the asthenosphere, so let's write that, we have the slab suction that is causing these plates to move. And in my cross section here, I have an oceanic plate moving to the left, an oceanic plate moving to the right. That's creating a divergent plate boundary, creating new ocean crust. And that oceanic plate is subducting down beneath this continental plate there. So that's a really clean example of two types of boundaries, divergent and our convergent boundary. And so two things are happening here. One of them is at this mid-ocean ridge, so a ridge in the middle of the ocean. Do you see how it's popped up right here? So at divergent plate boundaries between two pieces of oceanic crust, the crust is actually popped up. And so there's going to be extra pressure placed on that, kind of in this downward way, just because of the height of that. And so what's going to happen is it's going to put pressure on either direction away from that. And this is called ridge push. So it's actually pushing down on that plate, causing it to continue to move. Now the second example is going to be over here, where we've got this oceanic crust subducting down. And so as it's subducting down, the weight of that plate is going to help drive that plate down. And this is called slab pull. So it all starts with that convection that we talked about before, where we get that slab suction and things moving. And then the weight of the ridge, the weight of this slab subducting is going to help reinforce that process.